Yeah.
If you get into a collaboration with a controller tool in there, it's like
I didn't know if you changed your
subscription.
Yeah, no.
Like tunnels out to the server, so you can access that constraint. So
Yeah.
The other one is just
there's the one that like a side project you're developing. It's my sense is basically with and an NRM24, you can make devices that appear on the barrel just as like a button store.
Yeah.
That's where I heard about it, my sensors.
Yeah.
And yeah, that's fine. Just what led me down that path.
Yeah.
I'll check that out.
All right.
Thank you, Molly. Episode.
Yeah, they released a new version like a month ago.
Inside the things shouldn't go on the table. Table home functions. Yeah, sure. I told them to drop the million.
Three, two, and
Grace patience and, no, this one.
All right. And we are live, Reid.
I can understand. Like you said, you stop.
Yeah.
Really 10
This networking is very.
5.
Yeah, he was just testing.
I don't know why.
I don't know how many are here, but
Yeah.
5 people here.
Yeah, I often watch the event that I'm at on my phone while I'm at it.
Yeah, we got it.
I was doing all
So I was like,
all
well,
that.
So does it switch when I do?
That's just a whole stack for me. So I had it through working.
What would you use as the broker on Node, Moscow or something?
Yeah, yeah.
Okay.
But I was gonna see if I could use it as
you just get
actually,
in trouble because he's not actually, he's not doing this. Recipe for disaster.
turn on the service. bus.
Yeah, I'm familiar with that one. Yeah, like Rabbit supports that. Right. And actually Rabbit supports both MQT and MQTT. And you can use it as like a middleman. So if you want to go from MQTT to MQP, you can do that.
Seems a little behind.
Once you
Just letting that image build.
had a moment where I struggled with it. It has.
Yeah, it's a little
All right.
behind pages, but it's drink time.
Okay. So like it goes, actually use.
Yeah, that'd be awesome.
I gave the user read write.
If you're ready, I'll
And
leave
that
the
was
introductions
not
of it.
apparently.
Hey guys, I want to thank everybody for coming out today. First off, I want to thank Miss Ann from Premier for providing the food because, well, Reed's here today, so that's why we came. But I know the food's a big draw as well. But again, I want to thank everybody for coming out. A couple items of note, this past Tuesday afternoon, evening, we met at Windrock. Sorry. We did some live PEX coding and PEX for fun and some code wars kind of stuff. So we're going to continue on with that trend of some hands-on team type of mob programming. So if you're interested next month on the first Tuesday afternoon, we'll be doing some more of that. Also on the second Wednesday of October, we will be having another presenter come in talking about Meteor.js. I know it's not really something I've worked with a whole lot, but there'll be more details to follow on that. So join up on the meetup site, and that's where we'll be posting new information. So without much further introductions, this is Reid Evans. I've known Reid for a long time now. He was kind enough to come out and do a on-the-spot presentation for us on working with F# in the real world. Reid, I'll turn it over to you.
All right. Hello. So my name is Reid Evans. I'm a senior developer at Thomas Group. You can see on the board here, I've got a really official Notepad++ open with my credentials and stuff there. I'm on Twitter at Reid and Evans, and then you can see my blog there. I've got a lot of stuff on kind of getting into functional programming, specifically with F#. That's on there. And it's really targeted towards kind of getting getting into the language, getting started with the language. So Thomas, we were located downtown. We were always hiring. We have several awesome positions available right now. If you're interested, let me know, technical and non-technical. Basically, I got into F#, working on a project for them. It's a dealer management website for Freightliner.com, so which are owned by Daimler, which is a Fortune small number company. I'm not exactly sure what their rank is at this point. But it's a project that I did the data transfer in F# and to migrate from existing system to current system. And that ended up being so successful and so quick to production or whatever that we decided to continue focusing on, can we build the rest of the app in F#. So F# is a functional first language. You can do object-oriented coding in it if you'd like, though it's not the default. Here's what's basically, if you are in Visual Studio and you create a new project with F#, this is about what you're going to get. I went ahead and loaded up an external dependency. I wasn't sure what the Wi-Fi situation would be. So this is F# data, which you can just pull in through NuGet, or if there are actual, hardcore F#ers out there watching, you could also use Packet, which is probably what they would use. It's an alternative to NuGet that a lot of F#ers use. And then basically just add a connection string in here because we'll be talking about the database today. Anyone here have F# experience already? Seen it, worked with it at all? People, okay, awesome. How about .NET in general? .NET, yeah, okay. So a lot more hands. Okay, so F# targets the .NET framework just like C# does. Well, similar to the way that C# does, it all ends up running on the same basic, the CLR or whatever. So instead of going into long-winded definitions about what functional programming is, what I want to do in this talk is to, rather than say, all the stuff about it, is to really show you what some of that code might actually look like and how you can develop real stuff rather than just what's the project Euler or whatever things with them. You can actually write a lot of code really fast or provide a lot of value really fast, and it turns out to be not a whole lot of code. So one of the first things, let's just get started. One of the first things that I like to do is to define what my domain is going to be, right? So one of the things we can do is we'll say type location equals, and we're going to just basically then create this as a record type. This is immutable. Once it's there, it cannot change. It's kind of like a struct if you use the C#, except that the difference being in this case, it's going to automatically override equality. So you have it's not referential equality, it's value equality. And so we'll just have a let's do city and state. And so then in that case, we have just that simply, kind of looks like a little bit of a JSON kind of thing, but basically we've got a location type that has two properties. One is city, the other one is state, which should be pretty easy to reason about, even if you've not seen F# before. There's a cheat sheet somewhere here. The next thing that we probably want to do, so you've already see here that I've got a connection string signed up here. This is just to my local. We can open it up here and you can see what it is. It's just a really, really simple table. I didn't want to get too complex with this because I wanted to start out really simple and then have time for questions and perhaps some more advanced stuff if we have some time at the end. So let's look at databases here, sandbox, tables, locations, and we'll just select all those. Just kind of show you what we actually end up having here. So basically we got a collection of locations, city data, and we've got an auto ID. So one of the things we want to do is let's go ahead and start trying to connect to those, and let's get some of those back. So one of the things we can use, the very powerful feature, probably one of my favorite features in F# is flag providers. So we're going to call this type get locations, and it's going to be a SQL command provider. And what the SQL command provider takes, I don't know if you can see the IntelliSense there, but basically it takes the command text. So in this case, we're just going to select star from locations. I have to forget if you all don't see the actual type, uh, all the different properties and stuff like that. That's not good television. So what we have here, this is a type. This is basically saying it's a SQL command provider. And here's the text that we actually execute. It's a SQL command that we have. We've got connection string to the data sources. But the cool thing about this, you see everything's good here. And if I remove that S, we immediately know that our code will not compile. So checking that every single time. In this case, Visual Studio, as I'm editing it, will do it depending on what you actually have, which editor you're using. It may be at the compile step, but regardless, it's going to let you know, hey, there's something here. If we hover over this, you can't see it, but it actually says invalid object name location. It couldn't be executed. So that's a really powerful thing. It removes a complete whole class that you can have getting back and forth from your database. That is by itself, it's just a type. So to actually get locations, one of the things we'll do here is say let get locations. But about everything in F# is let. There is no things that you default. So it's not variable. So you're letting it equal a value. So function values, primitives are values, records values, unions actually want Create location, and that's going to be also another SQL command provider. Insert into locations. Where do we go? City, state. And then we got to pass our connection string, so that's which one to go against. And so then now we have this. So once again, there's no errors. If I were to put this as something weird, it would tell me that. Once again, same thing as we had up above with our select star from locations. Once again, this is only a type. So we'll, so this is basically this. If you're not used to F# in the way that it kind of you define things, this looks odd because there's no parentheses around it. There's no types telling us what these things are. And in fact, if we hover over these, it says the city is an A and state is a B. That's just its way of saying, I don't know what this is yet. Hopefully you'll put some other stuff in here to tell me what it really is in a bit. So let's do that. So let's say that our command, and these names are just arbitrary. It's just one of these there. So if we're going to do a new create location, and we're going to say command dot execute. And execute, if you see here, I don't know how readable that is. I can't really increase that, but it says, hey, I need a city, which is a string, and I need a state, which is also a string. So it's inferred from this type provider that this command, to call this command, we're going to pass a city and a state, and it knows that both of those have to be a string because that's what those are actually going to be when it gets inserted into location. And so then we say city, state. And in that case, it's going to return an int, just letting us know like how many rows were updated, right? And then if we go back to city now that we see the city is going to be a string. So the compiler automatically knows that because the only places that we're using city or state here are to call execute, which takes a string for both of those. So if we were to try to do something with city and state that wasn't something you could do on a string within this function, the compiler is going to throw an error. It's like you got to do one or the other. You can't do both. So then at that point, we can actually we can get locations. All this making sense so far? Yeah. Any questions?
Yeah, the part where it checks your SQL.
Mm-hmm.
Is that basic, or can it go down the rabbit hole? Like if you do some complex SQL, is it really going to evaluate it, or is it just looking at metadata of a table?
No, it will do any of the complex that you want.
Okay, so you throw something at it and you've done your partition by query wrong, it'll throw back the error that as if you were in Management Studio.
That's exactly correct. There's also in the same thing here. So this is if you're looking for it on NuGet or anything like that. It's the F# data SQL client. F#data.SQL client is where it is. It's got this SQL command provider. There's also a SQL programmability provider. So basically, you can point it at. Actually, I'll probably show that. Let's just say DB basically. So then in this case, we pass in our connection string. It's probably not going to tell us just a whole lot because, so you see right here, then we're saying, oh, which tables do we have? We have locations. So it's building all of this stuff up. If we had a store procedure that we wanted to call, tables. Yeah, so I don't have any store procedures defined in that, but you could do that. You could also do user-defined types. So if you need to pass table value parameters, you can absolutely do that as well. By just iterating, you can basically do a sequence map from whatever sequence you had to that kind of table type and just throw that right into a store procedure. So if you needed to do something where you've got a transaction around, I need to insert a parent and all of its children for it, right? You can keep your store procedure, you can keep your transaction there around it, and then actually call, one call that passes the table value parameters for all of your children, which I'm actually doing in. I may be able to show some of it. I don't want to perhaps give away any query strings or connection strings that may be found within some of the other code that I have. So I got to be careful when we run code UI video in there.
Is there any persistence packages or anything that would do a lot of this boilerplate stuff for you? So you could just write, say, an annotation on location and just a little table or something like that?
You probably could. So there are many different SQL type providers. There's several different ones. There's one for Entity Framework. There's one for Link to SQL. There's this one. I am a micro ORM kind of guy. So for me, I like going ahead and doing this. In this case, yeah, I mean, it's what we're doing here is trivial. But if you start writing anything that's a little bit more complex, I like being in control of what the SQL actually is. Trade-offs, right? There are others that will do more of this kind of legwork for you, where you're actually then dealing with, rather than text or a string, which gets turned into a SQL, you can just say basically, like how I was dotting through the database there, you can dot through and say basically, dv.locations, throw a predicate at it. You can absolutely do that kind of stuff. It's just, it's preference. I like knowing what it is on the bigger apps. So, or on the more complex queries, I should say. So one of the things I probably want to do, so that we can actually see what this is doing, right? It could be spun up easily. This code that we've got right here could be called by anything else. In fact, we could compile this and then actually execute it and reference that DLL from C# or any of the other CLR-based language VB if we wanted. We'd have no problem doing that. But one of the things that becomes really neat and necessary in functional coding, especially when you have immutable types, is recursion. Because you can't exactly do a while loop and then start modifying some state or checking whether some value has changed, because it won't, because it's a value, it's not a variable. So let's create a function here. We'll add the rec keyword, which basically says this function can be recursive. In other words, it can call itself. We'll call it console loop. And what we want this to also have is some way to say, let's get the input. So basically, we're going to create a REPL. So everyone know what REPL is. It's a read about print loop. So we're going to say console loop, and we're going to say, get input. And so then at this point, what we'll do is we'll say, if you're used to the C# or the .NET, let's go up here and let's open the system, just so we have it. It's kind of like a using in C#, which is basically what it is. Let's say console.write. Let's do a little caret, so it makes it look like we're actually in the read about print loop. Then what we want to do is we want to let input equal get input, and we'll pass unit there again. And then what we want to do with the input, basically what we're going to have is, it's going to be just a string, right? So we want to split that. So if we're going to split it, we could use string.split. But if we do that, then we have to explicitly say that this input is a string, which we can do actually, I guess. So we can say that. So then now we know that input is string. So basically by default, then it's going to say it thinks it's going to return an object. Once we actually start calling into console loop, it'll know what it is. But for IntelliSense purposes, this kind of helps. So once we have that, we can then say let args equal input. Split on the space there. And so then args is going to be a string. You notice as I'm typing, this thing comes up and basically it's saying it's expecting an expression. So basically it thinks it's expecting this to return something. And because we haven't returned anything at all, the last thing was a binding. It's going to cause, it thinks it should cause an error, but we'll see what this should be. So one of the things that we're going to do is then eventually what we're going to do is we're going to get down here, we're going to do some sort of logic, and then we're going to call console loop get input, right? So this is just calling itself again with the exact same parameters or arguments that it received. That's not always the case with a recursive function, but in this case, This is like the equivalent of a while true kind of loop if you're from an imperative kind of background. So one of the things that we have this, now let's match, we're gonna do what's called a match expression, pattern matching. And you can think of this kind of as like a super switch statement. So if you're used to switch statements, this is kind of like that, only it's got a lot more power. So what we're gonna do is we're gonna say match args with, and we're gonna define all of our different cases down here. So one of the cases that we probably want is we want, let's say it comes in and what it's going to be is an array. If args is an array and the first element is get, and there's only one element, then what we want to do is we want to call get locations, pass unit, and that's going to return a sequence of locations. So what we want to do then is we want to pipe. You may have seen me do this earlier too. So pipe is a way to, it just kind of inverts the stuff. Basically it says, let's do this and then take the result of that and put it into call it into the next function that we have. So our next function, let's just do, just so we can see it, we'll just say printfn and then we'll do like %a, which will basically just take that and kind of do pretty printing for us. That's another thing that you get with immutable record types, is it's going to automatically kind of handle the pretty print for you. Another one we want, let's say we have for our insert. So let's do add. So if we have add as our first argument in the list, and then the next one we're going to say city, state. What that's going to do is it's going to say if the arguments have 3 elements in it. If there are 3 elements in that array, the first one's add, and then the second one is city, which is a variable, so it's going to actually define this to it. Then what we can do is we can say create location, city state, and we can pipe that then into printfn %i records inserted. And then at that point, if we were to actually run this, then what we're able to do is then in the console app, we're able to do that. We're able to get all the records, we're able to add records. One of the problems though is that when you do a match statement, it has to be complete. So if we hover over args, you see we have a squiggly, it's telling me that I have an incomplete pattern match. In other words, there is a case that I have not provided a possibility for that could happen, and the compiler doesn't want you to do that. So basically it forces you to either handle everything, or this is a way to basically say, for everything else, let's do it here. And then in that case, let's just say, you know, invalid argument or something, right? So then our entry point, let's just call into our console loop. To call into our console loop, we have to pass something that's gonna fit this signature. And as it turns out, console.readline actually works really well. And so then that's saved. So in the match, in this case, we're matching on which we can match on specific strings, or we can actually then also destructure into variables that we can use later, which becomes really powerful. To see this work, the downside is I'm not going to be able to zoom in on that too much, but we can say get. And if we enter that, then we see we got a sequence, and it's got 1 element, and the city is Knoxville, and the state is Tennessee. We can add, who do we want to add? Chattanooga? How do you spell Chattanooga? We'll say yes. Chattanooga TN, 1 record inserted. If we do get again, then we see that we now have an array with 2. Right? So the point of doing this in a console app and making it look as a REPL is just so that I don't have some other huge framework that is doing some of that magic for us, right? There's not a whole lot that has to go into that. Plus, then you get to see the match expression, and you get to see some of the being able to use recursion and how that kind of works. Any questions there?
Yeah, I'm a little confused by the get input there. So you've got it as an argument, then you call it, which I assume calls console readline.
Yes.
Then why does the recursion, the tail recursion there, pass get input again? I guess I don't understand why wouldn't you get the same, first line again, rather than like get input tail or something.
Sure. So if I call console input right here, I can absolutely do that. Well, sort of. The problem is that console input itself can be only partially applied. So to actually call this function, you have to call this function with all of the arguments required for it. Otherwise, you get another function. So
is the argument a function or an array?
in this case, get input is a value, which when given a unit will return you a string. So in this case, unit being open paren, close paren. So in this case, when we say get input and pass this, then get input, because we've called it console loop and we passed console read line, which if we look at console read line, when given a unit, it returns a string. So the function signatures match up, and so it's perfectly fine for me to do that. I could have also, I could have done something where I said, I created a specific type that was that. I could wrap console read line in a function that does that, but it's really the same thing. If you remember back to like math days, we can cross out, if you've got, a 5 in the numerator and a 5 in the denominator, we got 1, right? It's that kind of thing, is that you can continue to
Yeah, I guess I was
just remove
thinking to languages like Miranda that model the input as like an infinite array. Something like that.
And that's basically at this point what ARGV does. So this is an argument that is basically is a string list, but that's just kind of by default because of the .NET framework and how it spins up a console application.
I have a question.
Yeah.
What does that do to your call stack?
So in this case, my call stack is perfectly fine. However, and F# does have tail call optimization. What that basically means is, in this case, when I'm calling console loop, I'm passing everything that the next iteration of console loop of this function that it needs to know to do its job. If I did something like calling console loop with the result of the previous console loop, then it would have to keep a reference to that going all the way back. This is something that is a common source of error in JavaScript, where it doesn't have tail call optimization, but it doesn't try to help you out there. And you're back, it gets as big as many recursion limit, as many times as you recurse through it. But if it can handle everything already, and a common way to do that is to add an accumulator to it if you've got a situation like that.
So the fact that you have nothing after your recursive call, it can optimize that.
This each iteration of this recursion call of this function can do everything it needs to based on specific values that have been inserted in. It's not waiting on some other function to run, so you don't have the kind of nested recursion calls. All still good? We want to see some more? Have more questions? More? Okay. All right, cool. Made it to the back page. All right, so here's some extras. So one of the things that we would probably want to do, or that we may want to do, well, I'll let you all decide. We want to see how we do the async stuff. Or do we want to see how we get by when we say that we don't have the concept of null? Which would you all prefer to see? How we handle not having null in the language, or how async happens?
Async.
Async. Okay. Let's do async because it's actually pretty quick. So in this case, in our get locations, and actually the cool thing is they're both based on the exact same concept underlying, but I don't want to go into that just yet. So in our get locations, if we wanted to turn get locations into an async non-blocking call, so basically call goes out to the database, we're not going to block on it, we're going to let the database do whatever it needs to do, and then when it comes back, we'll figure out what we need to do. If you're used to C# with the async and await, or in what I call ES7, was supposed to be ES 2016 now, they're going to have async and await in there as well. Basically, what we can do is we can say async, which in this case is actually a computation expression. We can wrap that in parens. And what we'll do is we'll use a special syntax. We're going to say let the result, and you see we've got let bang equals query async. So we're just going to call the async execute method on it. And then what we'll do is we will return result sequence map to location. This function is not completely async, right? So it's almost the same code. We did have to call into a different method here, a different method. It actually is a method in this case, not a function. We're calling into async execute, which returns an async generic, which is very similar to the, actually, I think I'm saying this right, predates the task from C#, but it's basically returning the same kind of thing. If we look at locations now, what we see now is that it returns an async of a sequence of a location. That's going to mess us up down here, right? Because we're going to try to print something that doesn't exist. So then one thing we can do is at our application boundary, we can say asynchronous synchronously, and then pipe that result through printfn. If we stop and restart, this should work. And you see it still works. The difference being that at no point while we were going, since we're on the same machine, we don't get a double hit for processing time on SQL while our application is still waiting, right? So to do that it's really trivial. We wrap whatever we're doing in the async, it's called a computation expression. We use let bang whenever we want to do it. So instead of doing like the await keyword in C#, we're going to actually say let bang, which is going to do the same kind of work. So if we look here, result is a record. Result is not an async of a collection of a record, which if we didn't do let bang here, we would see that result is an async of a collection of a record. But doing the bang says, hey, you know what? When that returns, go ahead. I don't care about the async. Take off that wrapper part, and I want to deal with the actual underlying thing that's underlying that data type.
Is that kind of the same magic that the like an async in whatever it is, .NET 4.5, that
Yes.
it's a task of T, and then the IntelliSense allows it to treat it as a T instead?
That is exactly correct. It's used by the exact same underlying thing. F# has had this for a while. I don't want to say it's not 10 years, but I'm wanting to say close to 9 years now that it's had this. And what gets really cool is that rather than it being something that the compiler is doing for you, you can actually write these. So you could write something that you have the power to write these things rather than it being something that the compiler allows you to do through some sort of compiler trick, which is what async and await in C# does for you. So that's a way to do the async. We can go from that right into the other. How am I doing on time? How long do we have?
You're gonna allow.
Oh, okay, cool. Cool. So one of the other things that we could do, a common way of doing this is actually is a concept known as maybe, which is the way that in a functional language that doesn't have null, which by the way, you don't have to be in a functional language to not have null. It just is that most of the object-oriented languages that are popular have the concept of null. There's nothing wrong with null except when you have a language that every single thing in the language can be null. So then what do you have at the beginning of all your methods, right? You've got to check to see if one of your arguments is null coming in, because you've got to protect yourself against what's coming into it. In F# in functional languages that, or in languages that don't have null, they have what's called as a maybe, or in F# they call it an option. And so if we look at an option is either a sum of T, or so it basically looks like it's built into the language, but it's a sum of T or it's none. So that's basically what it would look like, or something similar to that, except it's actually a discriminated union, which actually here, let me just show you what that looks like. I haven't read a discriminated union in a while. basically looks like that. Basically, it's saying that the option type is either, it's kind of like people tell me when I say that it's kind of like an enum, that that's not at all what it is. But basically, it's either one of these two cases, and if it's a sum, then it also has the argument that it's either. If it's a none, it doesn't need anything else for it. And if I weren't live coding, I would be able to write that very easily. So what we can do, let's take a place where that where we could use that ported into here. So one of the places where we could easily see that is if we were going to have a type that was get location by ID, right? Because we can't return null. What do we do if the ID that we've queried doesn't exist, right? So that's the kind of problem that we have. One of the things that happens when you code in languages that don't require many lines of code is your typing starts to suffer. So I apologize for the slow typing. So ID, and then what we'll do here is use the location by ID and query that. Sometimes it takes the compiler a little bit because it's got to go out and check the external resource and come back there. So we can execute that ID. If you notice here, it's still thinking it's going to return an IEnumerable. One of the things that we have the ability to do in this case is we can pass another option to this and say single row equal true. And what ends up happening there is that execute then returns an option of that record. So it may be an option or it may be none. So if nothing came back, then it's going to be none. This entire function then returns an option of that. And what we can do, if we start calling into this, we can't actually deal with what the object is unless we handle both cases. So we're explicitly forced to deal with the fact that it might be something or it might be nothing, which seems prohibitive until you realize that there's very few points in time where that actually has to happen. And all the time you're spending time checking for null and to manage those kind of arguments, you don't have to do that anymore. It's only in very, very specific places that you have to actually handle that something may not exist. A common example is division, right? You can by any two numbers, right? Unless one of them's 0. So what do you do if you're dividing by something? If you say 4 divided by 2, okay, well, that's 2. That's perfectly fine. But what's 4 divided by 0, right? The joke goes, only Chuck Norris knows that, right? So you can throw an exception. You can return null, except that in the .NET framework, you can't return null on an int because that's not true. So what do? Return a nullable int? Well, with a functional language that doesn't have null but has an option type, what you end up doing is you just return none. Right? Can't give you the answer for that. Throwing an exception seems like we're breaking the idea of the function of the method, because the method function is the method's signature says that given two numbers, I'm going to return you a number, but that's not true. That's a fake signature, because if one of those numbers, if the denominator specifically is 0, I'm not going to return you a number. I'm going to throw an exception, or I'm going to return a null, or I'm going to do something like that. So actually having that ends up being really beneficial, and is another whole class of errors that you simply don't have to worry about. So if we wanted to actually see what it would look like, we can throw this into our console app here. We'll say get, and then the second one will be whatever the ID is. And then what we'll do is we'll say that we want to get location by ID. And what we're going to have to pass into that is actually this ID, and then we're going to have to say parse. Because in this case, what I'm doing is get location by ID, location by ID. In this case, obviously, we split these into strings, so it knows that the ID has to be a string, and what we actually want is for it to be then once again say print percentage. Get our pretty printing. Does that work?
When calling out to .NET framework methods like paths, have they been annotated somewhere so that the F# compiler knows that they have no side effects?
Not completely, because in this case, you're very right. Parse can throw an exception. We get it from IntelliSense here, but it's not guaranteed. Right? There is a try parse, which we could call to, but and in that case, try parse is actually kind of cool the way that they wrapped it. It actually returns a tuple. So with tuple, the first one is the result, the try part, and then the second option, the second value in the tuple is actually the result or none.
What about just the user defined function? If I just went in C# and define a function here for the, write some data to disk or something.
Yeah,
So that's got a side effect. But if I have a side effect free function that just adds two numbers or something, can I mark that as such so that F# knows that it can optimize it?
No, at this point, not to my knowledge. Not to my knowledge. So it's one of those things where F# is great and it's functional by default and all of these good things, but it's sitting on top of the .NET framework, which was written in an object-oriented manner that has nulls, that throws exceptions, that does all of those things. So unfortunately, it's not completely safe from that manner, but it's usually pretty obvious when you're calling into one of the .NET functions or methods, and when you're doing that, it becomes pretty, it's kind of like triggers warnings in your head if you've been doing it, but to your point, it's not pure like a Haskell would be, where to write to the console, we would have to wrap that in an IO and actually deal with that. So it doesn't have that kind of pureness to it. So if we say get 2, then we see our see what it actually returns is sum of that. If we say get 9, then we actually get null. It's the way that pretty prints the none option for you. But if you don't define something as an option, it can be null if it's not one of the .NET types or whatever.
So what happens if parse throws an exception?
In this case, it would throw an exception in our code. Yeah. Yes. So actually, what would that get food? Yeah. So it will blow up because, and that's the risk that you run when you start accessing one of the .NET libraries that does, or one of the .NET functions that throws an exception. So yeah, it will still fail if you do it that way. So let's see, we've still got a little bit of time. Let's go and do, let's do our divide by. So what we're going to do is we're going to say, if b equals 0, then none, else sum a divided by b. All right, so that's a way to write a pure function in there, right? So it takes in this case, it's that they're ints because it's the easiest thing for it to do. And then it's going to return an option. One of the things that's really neat is I can, unfortunately it's tough to see because I can't zoom in on it, but I can, you can do Alt-Enter through here, and then actually it will automatically drop you into a REPL. So then within here I can say, divide by 4, 2. And then it says an option sum of 2. If I say divide by 4, 0, then the option is none. The result is none. Notice that even when it's none, it still knows that it's an option. So it's still strongly typed. It knows that's what it has to be because that's what the function of this signature says, even though we haven't defined any of that.
So could you do divide by 4.0 too? And it'd be smart enough to figure out it was double or whatever.
Yeah, so like no, we could write a function that did that, but in this case, that once again is it's using the underlying implementation of divide by, which is defined in the .NET.
So you have to explicitly say that this is a double?
Yeah.
Okay.
Yeah, it's the same, you run into the same problems there that you run into with the .NET framework, especially if you've got, yeah, what's 3 divided by 2? Right? It's not what you think.
Yeah, but there are some types that can be coerced into others.
Right, right. So let's see what, yeah, like 3 and 2, right, someone, and they complain about JavaScript ban, but I digress. So those are some of the things. One of the things with this is the one potential problem is, or what you may see as a problem is that if we have, if we return this sum of 1, so this returns an option, we can't chain divide by false anymore, right? Because option doesn't know how to divide. One of the things we can do, and going back to my comment about this async keyword here being the computation expression and us being able to write them, what we can do, I think, is we'll call maybe builder. It's going to be that way. And we'll say x find. That doesn't work. It's going to be unique. And we'll set the return, takes sum, and takes x and wraps it in sum. Doesn't it like here? I have my arguments. Next, no. Tell you what, let's cheat. I have this code other places. All right, so, well, here I just explicitly actually did that. So if we could write this, let's just copy this. Paste it over here so we can play around. So now that we've got that, we can let maybe equal new maybe builder. This maybe builder here, actually, by the way, is essentially how you class an instruction. You can say type equals. This actually ends up being the constructor for it, and when you say member, whatever you use as member, it does that. But it's also a way of declaring computation expressions. And so I say maybe let 2 equal divide by or 2, and then once again, so if we do this, it wants this to be in a function, but if we do, it's the same up here with the async, and the async, if we don't do our let bang here, then result in this case is an async of those, but if we do, it unwraps that top level of the async, and result we're actually dealing with it as non-async, so it's just the collection underneath. What we're doing down here is the exact same thing. In this case, 2. Say by food. So in this case, 2 says it's an int. Right? Because we're unbinding, we're taking off that outer wrap. If we don't have this, then 2 is an option. So then one of the questions that you may have is, well, what if we do something else after this? I was used to working. And it takes four, and it only ever calls that four. Once you get things like lists are based on the same underlying list. And in that case, it's not pulling on that into memory. So it depends on what underlying type you're dealing with. But you can do, like where I did async, run synchronously. We had a whole bunch of things that needed to happen. They could all run parallel. There's an async not parallel. Just execute all of them, and then we could what we could do. So we could do async parallel, async run synchronously, and it would run all those parallel, and it will continue once all of those things completed. But just means to call back. That's correct. That's correct. You can also, if you're dealing with it, you may also see someone you see if we just do, and what the same thing.
Can you have this done by Friday?
Sure.
No.
Yeah.
Right, always.
Always.
Just because it's wrong.
That's right.
And start trying to consider, okay, how I want
services, which generally, especially in enterprise, that's a very good thing to do. You can absolutely do that. You just don't have to worry with creating a structure, defining what those things have to be, and then having to have an interface and then a class that implements the interface to the inject. So it's infinite constructor injection, essentially.
Okay. Well, we've got about 3 more minutes. So we might have we have time for one last question if anyone has it.
How is the performance of the compiler? So if things are being passed around immediately by value, there's potential there for a lot of copying going on. Is it smart enough to pretty much?
So what it can do, if we had, for instance, we had our location here that was sitting in a state, if it is, we could set the location in, so I could say, create a function called and set the location. What we can actually do is for the condition to say location with state equal DM. So then it'll just, I don't do that often, but what that's actually going to do is create a copy of that and then pass it on. If the previous one of it was not used, then it would be, subject to garbage collection because it's still all was built on the garbage collection. But the result here would be different than, it's a different, it potentially is a different value, right? The result of this, if location already has state of Tennessee, the result before it and the result after it would still equal each other because it still has the same, it's still the same thing. Value of all.
Excellent.
Structural.